Buenos días, mi nombre es John Villamil y voy a exponer sobre la fundición, sus propiedades y sus materiales. La fundición es el proceso de fabricación de piezas metálicas. Eh, pues básicamente metálicas, pero también pueden ser plásticas. Consiste en fundir un material e introducirlo en una cavidad, en un molde. Y con este molde hacerla solidificar para que quede apta para tal pieza. Las propiedades de la fundición es el contenido de elementos de aleación, la ausencia de efectos internos, la distribución de la habitación, el tipo de microestructura obtenida, la finura de la microestructura y elementos de microaleación. Los materiales de la fundición son tal como la arena o la arcilla para el modelo o molde.
Casting in permanent matrix. This process is different than other casting processes due to the matrix can be used more than once. Matrix materials. Those materials must have a high melting point. This to withstand erosion by the liquid metal at powering temperatures, given the necessary strength so that the matrix doesn't deform. It must also have high thermal fatigue resistance due to the premature cracking. The cracks can leave marks that ruin all the final cost. The matrix material can be cast iron, even though steel alloys are mostly commonly used. For the cast of high melting alloys, such as brass or ferro materials, the matrix steel must have considerable proportion of stable carbides so that resistance to high temperatures can be retained. Graphite matrices generally are used for steel, even though only can be used in simple ways. The coatings can be chosen according to the cast temperature. Matrix design. All the permanent matrices have common features. Those are: first, it's really important that solidified as can be removed easily from the matrix cavity. In this way, the shapes that can be produced are more limited than in a casting disposable matrix. Second, the internal cavities are formed with the help of fixed or mobile metal cores. The skewed shapes require that the cores be made in several interlaced parts, which are removed in a fixed sequence. 3. Niches in matrix allow that exact location of inserts such as 3D inserts, hidden elements, etc. 4. The ejection bolts are necessary to remove the solidified cast iron, especially if the process is much neat. The number and location of the ejection bolt must be chosen to avoid unacceptable surface marks on or cast distortion. 5. Fifth, matrix materials is not permeable. Therefore, pores must be provided to avoid catching gases. The clearance along the separation planes and around the ejection bolt can also serve as pores. Solidification. The permanent mold works like a heat exchanger. At the start of production, the mold must be preheated to the desired temperature, generally between 150 and 200 Celsius degree for zinc, 250 to 275 Celsius degree for magnesium, between 225 and 300 Celsius degree for aluminium, and 300 at 700 Celsius degree for copper alloys. The heat released by the solidification is removed through of radiation fines or bolts. There are three ways to classify casting in permanent matrices. First, casting in permanent mold fitted by gravity. Frequently, This process is called the permanent mold casting or die casting by gravity. This process is based on the same principle as disposable mold casting, but the mold is made with an appropriated permanent material. This process is widely used in aluminum alloys as well as magnesium and copper alloys. Found dries of cast iron and steel also can be smaller. The mold is protected with a coating lubricant for the magnesium and aluminum alloys. Second, casting in permanent matrix with lower pressures. The mold is placed above the melting furnace and the metal is fed by air under pressure through the lower discharge hatch to the mold cavity, ensuring a smooth filling. The solidification is directed from the top down, that the air pressure is released as soon as the cavity is filled with liquid metal. In this way, material losses are minimized. The thin coating ensures an acceptable surface quality. Die casting. These casting processes consist in fill the matrix cavity with high pressure, making the cast metal fill completely all the cavity details, something that with lower pressures it could be done. It couldn't be done. Both halves keep joining through the high force. It's something that works like an hydraulic press. Due this, die casting matrices are classified by closed strength, starting in 40 meganewtons. To avoid stiffness, matrices are closed by layered jaws, while the fusion forces until the matrix through are separate longer. This is slow at the beginning and then turns into a faster speed. It's very important to apply lubricant to the matrix surface in each process. It could be graphite with an oily base diluted in water. All these processes can be mechanized.
In the cold chamber process, molten metal is introduced into the injector cylinder. The shot chamber is not heated, hence the term cold chamber. The metal is forced into the die cavity at pressures typical ranging from 20 and 70 megapascals, although they may be as high as 150 megapascals. The machines may be horizontal or vertical. Aluminum, magnesium, and copper alloys are often caused by this method, although other metals, including ferrous metals, are also caused. Molten metal temperatures start at about 600 centigrade degrees for aluminum and magnesium alloys and increase considerably for copper-based and iron-based alloys. How is this process equipment? In the principal parts are furnace, a die and die casting machine, and an additional equipment a die temperature controller, a die reciprocator sprayer, and extractor robot. At the moment of making the casting process comes out a piece formed of biscuit, runners, and overflow as shown in the image. The matrix is composed of two parts essentially, which are a cover and an injection bolts. The main functions of the cold chamber matrix process are keep the two halves of the matrix firmly together and inject the molten metals and the correct speed and under high pressure into the cavity of the matrix. The machines are classified by the tons applied to the matrix to keep in closed, ranging from 10 tons to 3,000 tons.
Les voy a hablar acerca del procedimiento de fusión en cámara caliente. Este procedimiento se realiza cuando un cilindro es sumergido en un metal derretido. Para este procedimiento necesitamos la ayuda de un pistón, el cual va a ser el encargado de atrapar un volumen específico de metal derretido y empujarlo hacia una cavidad de troquel, a través de un cuello de cisne y una boquilla. Esta presión que realiza el pistón debe ser superior a los 35 megapascales. Siguiendo con el proceso de fusión en cámara y caliente, el metal se mantiene bajo presión hasta que se solidifique en el troquel totalmente. Para hacer un enfriamiento rápidamente y así mejorar su productividad, los troqueles se enfrían mediante la circulación de aguas aceites a través de unos pasajes que se encuentran en el bloque del troquel. Para este tipo de procesos en cámara y caliente se utilizan materiales con bajo punto de fusión y que no sean corrosivos, como lo son el zinc, el estaño y el plomo.
What sets the cold chamber process apart from the hot chamber process is the shot end. In this cold chamber injector process is outside the vat of the molten material, while in the hot chamber is it inside. To finish, precautions. The first, keep the injection system and both parts of the matrix with a lubricator. To support constant temperatures, before making the first injection, the matrix must the preheater open the cooling valve gradually to avoid defects in the piece and to use tools of bronze.